So in this video, we'll be talking about the theory behind implicit differentiation. So while we learned the problem-solving strategy behind implicit differentiation in the previous video, and that's pretty much all you'll honestly need to know while doing most of your work with this theory kind of explores the deeper ideas of why implicit differentiation works and what we're actually doing here on the lower levels. Okay, so this hopefully will help you gain a better grasp of what we're really doing in implicit differentiation and really help you understand the concept better. And this will come in handy, especially when we do things like related rates, where we'll be using a lot of different kinds of implicit differentiation and it'll be a lot easier to understand the theory as opposed to just like a couple of steps. All right, so let's go ahead and talk about that then. So there are three postulates that I've put together here, and we're going to talk about each of them. So number one, y is a function of x. So really key to understand. So y is not, so you can't treat y like you treat x because y is not x, but y is a function of x. All right, so that's how we're going to be treating y as a function of x. Okay, so therefore anything with a y in it is a composition of functions. That makes sense, right? Because if you had like two functions put together, you'd have a composition. So if we assume that y is a function of x, right, anything that has a y in it is a composition of functions. So if we had a sine of y, then that's a composition of functions. All right, so that's basically the idea here. Then finally, therefore, when taking the derivative, the chain rule will come into play, meaning that we'll need the dy dx. If you really recall in the previous video, we talked about how we take the derivative of the function just as we would normally and then tag on that dy dx at the end. This is why we need that dy dx, because we're thinking of y as a function of x, right? Which means that you're going to have a composition of functions, and therefore you'll need that dy dx as part of the chain rule. Now, I may have lost you a little bit here in all the words, so let's go ahead and do this with a quick sort of example. Okay, let's think about this. Let's see 1 plus x equals let's see cosine of y. Let's think about that. All right, so let's take a look at just the cosine part for a second. Let's ignore the 1 plus x just for now. So let's take this apart. So we've got the cosine here, and we've also got the y inside. So do you see how this is a composition of functions? So on the outside we have f of x, which is equal to cosine of y, or cosine of x, right? F of x equals cosine of x on the outside, and on the inside we have g of x equals y, right? And remember, because y is a function of x, we can basically say this, right? So therefore, what we really have here, right, in this part, is we have a composition of functions. So we have something in the form of f of g of x, right? So when we take the derivative of that, okay, so when we take the derivative of this, we'll need to employ the chain rule. And the chain rule is as follows, equal to f prime of g of x times g prime of x. Right? So let's look at what each of these would be in the context of this problem. So if we took the derivative of everything, then this we would just derive as normal, right? Because we just derive that as usual because we have an x, so we just derive that as usual. But now let's look at what we've got here with our cosine of y. So we've got a chain rule here, right? Because we've got the cosine as our f of x and our y as our g of x. So we've got a composition of functions there. And so we know that by the chain rule, the derivative of that composition, right, would be f prime of g of x times g prime of x. So let's explore what each of those would be. So f prime of g of x would be the derivative of the outermost function with the inner function inside. So in the context of our problem, that would be sine or negative sine of y, right? So the derivative of the cosine, but keeping the y inside. So this would be the step where we just derive as normal. Remember that? Remember when we do implicit differentiation, we derive everything as normal, and then we tag on the dy dx, right? Remember that? So this would be the derive. This would be where the derive as normal comes from, because we have to take the derivative of the outer function, right? So that's where the derive as normal would come from, and the g prime of x would be the derivative of y, which is just simply dy dx. That, ladies and gentlemen, is where you get your dy dx from. Right? So that's how it's done. So this is where you derive as normal, and then that's where you get your dy dx. All right, so quick recap. We're going to assume that y is a function of x, okay? Y is a function of x. Therefore, anything with a y in it makes it a composition of functions. All right, so that's what we see here. The cosine of y, we see that f of x, our outer function, is going to be the cosine of x, and our inner function is going to be y, again, which we can say because y is a function of x. And therefore, when taking the derivative, the chain rule means that we'll need to have the dy dx. And we see this here because the chain rule says that f prime of this chain rule of this composition says that the derivative of this composition would be f prime of g of x times g prime of x. And the f prime of g of x would be the derivative of the outer part, we're ignoring the inner part, which is what our quote-unquote derive as normal comes from, because when we derive everything on the outside, that's basically what this takes into account. And then the dy dx comes as a result of this part of the composition over here, the derivative of the innermost function. Anyways, I hope that was helpful for you. I hope that helped you understand what we're really doing here in terms of implicit differentiation. So yeah, as always, thank you so much for watching. It's always a pleasure to make these videos. I hope you found it helpful. Please do leave a comment if you have any constructive feedback. Please like, share if you found it helpful, and just leave me a subscribe as well. That would be really, really nice. So thank you so much for watching. Have a great day.